We have seen in an earlier unit how to calculate the sample mean and variance for a set of data. Both of these calculations are examples of a more general set of sample statistics called sample moments. In this unit, we shall look at the more general idea of sample moments. We will also look at one particular sample moment, the third central moment, which gives us an indication of the degree of skewness in a particular data set. We define the kth order sample moment about alpha to be the sum of the kth powers of the deviations of the sample values from alpha divided by n, the sample size. Alpha can be any number we like, although it would be unusual to need any value for alpha other than either the sample mean or 0. Moments about the sample mean are known as central moments. Moments about 0 are known as non-central moments. Suppose we want the second and third sample moments about the mean for the small sample data we were using earlier. We first need to find the sum of the sample values, together with the sum of the squares and the sum of the cubes. The figures for these statistics are given here. The calculation for the second order sample moment is given here. The whole calculation is almost identical to the calculation for the sample variance. Note, however, that the moment calculation uses a denominator of n, whereas it is usual to use n-1 when calculating the sample variance. To find the third order sample moment, we need to calculate the value of the sum of xi minus x bar all cubed. To calculate this, it is usually easier to expand the bracket. If we separate the summations and combine the last two terms, we obtain a third order sample moment of about minus 1914. The fourth order sample moment is also calculated occasionally. It provides us with a measure of how spiky the distribution is. This is called the kurtosis. A set of sample values for which the frequency densities are similar will have low kurtosis. If the distribution is very peaked, then the kurtosis will be larger. We now look in more detail at the idea of skewness. Here are some examples of bar charts for different sets of sample data. Our first bar chart uses the data for the numbers of motor claims that we saw in a previous unit. Here, there is a marked tail to the right of the distribution. We say that the sample data here are positively skewed. If we calculate the third central moment for these data, we find that they have a third central moment of plus 0.8454. In the second bar chart, the opposite is the case. Here the sample data has a long tail to the left. Here we say that the data are negatively skewed. If we calculate the third central moment for these data, we obtain a value of minus 0.8454. It has to be said that motor claims data is very unlikely to follow this sort of distribution. In our third bar chart, the data is symmetrical. There are equal tails to the right and to the left. The value of the third central moment for these data is 0. Again, it is unlikely that motor claims data would conform to a distribution with this shape. You should check that you can carry out the calculations to confirm the figures given on the previous slides. To enable you to do this, The figures for the frequencies underlying the 3 bar charts are given here. Unfortunately, figures for the third central moment can sometimes become rather large and unwieldy. An alternative way to calculate skewness is to use the coefficient of skewness. This is the third order sample moment about the mean divided by the cube of the sample standard deviation. When calculating the sample standard deviation here, we use the n-denominator convention to calculate the standard deviation. Alternatively, we can think of the expression in the denominator as being the second central moment raised to the power of 1.5. For the bar chart data here, the coefficients of skewness come out to be plus 2.055, minus 2.055, and 0. You may wish to see if you can agree these figures. In fact, the coefficient of skewness can theoretically take any value. The coefficient of skewness is a dimensionless quantity, so its value does not depend on the units used for the original sample data. So, if we were to calculate the coefficient of skewness for the small sample data used earlier in this unit, it wouldn't matter whether our claim amounts had been calculated using pounds or dollars. The coefficient of skewness would be the same, whereas the value of the third central moment would depend on the currency of measurement chosen. Here is a summary of what we have covered in this unit.